Hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are again going to talk about an integrals generalization in this video. You know what? This is really crazy, and like the generalization, I like generalizations of integrals or infinite series or products. You might have noticed the pattern of my videos. I rarely bring something out of this, right? Okay, so I would like to show you a screenshot of my channels, actually of my channel. Here it is. So I have proved an integral 1 month ago, right? And I hope you have watched that, and if you haven't, please, it's your responsibility, please just watch that video. Okay, because I took 42 minutes 51 seconds to 6 seconds to prove this integral down, and it was really crazy, and this was one of the craziest integrals that I have ever proved in my life. Okay, so it's the integral from 0 to infinity of x to the n minus 1 over 1 plus x dx, and it evaluates to pi over sine times sine of pi n. Wow, this is crazy. And you know what? Like the result that we are having from that integral, the integral from 0 to infinity of x to the n minus 1 over 1 plus x dx equals pi over sine pi n. This is known as, like, let me just show you. So gamma of z times gamma of 1 minus z equals, or let's consider n here because we are having n. So gamma of n times gamma of 1 minus n is sine of pi n, and this is known as the Euler's reflection formula. And I have proved this down a lot of times, I think, so you can just check that out if you want. But we have proved this. It was very easy to prove this down, but this one was really beast, and it literally took more than 40 minutes, actually more than 42 minutes to be proven. And actually I wasn't playing around with that, I was proving it in detail, but still it took a lot of time to be proven, so that was really crazy. So now we are just going to take a step a little ahead of the thing that we have proved here. That is, we are again here to generalize. Well, for the case that we have proved in this video, n equals 1 from this video. So with the help of this result that I have proved, we are just going to evaluate this integral as well. Yeah, okay, so let's just evaluate this. I think I just have to keep this short, so for that case we have to just keep going on. So I just have to let x to the n equals t, right? The first use sub here, and this is the last one as well. So x is t to the 1 over n, and from here we can say n to the x, n times x to the n minus 1 dx is dt. So dx equals dt over n times x to the n minus 1, or from here we can say dx is dt over n x to the n over x. So we are having x to the n and x to the 1 as well. So finally we are having dx equals dt over, it's n times x to the n was t, and it's t to the 1 over n, and we can also say that it's t to the 1 over n dt over n times t. So yeah, this is what we are having for our dx. Okay, so let's just do this u sub here. And you know what, if we talk about the limits, so when you replace x as infinity, so t would be infinity as well, and if we talk about 0, so t is also 0. So limits ain't gonna bother us anymore, so our integral becomes integral from 0 to infinity of, well, x is going to be t to the 1 over n, so it's t to the 1 over n to the m minus 1 over, and it was 1 plus t because we assumed x to the n as t, right? And our dt as t to the 1 over n dt actually dx comes out to be t to the 1 over n times dt of over n times t. Well, let's just solve this something a little bit here. So 1 over n comes out front because it's a factor, so the integral from 0 to infinity of t to the m over n minus, or maybe we can say that t to the negative 1 over n here, and we are having t to the 1 over n and dt in numerator, and in for denominator we are having 1 plus t times t. Okay, now we can say that it's t to the 1 over n times t to the negative 1 over n getting cancels out with each other and leaving us 1, so that's a pretty good thing. And it's t to the m over n, t to the negative 1, this factor or this term, and 1 plus t dt. Well, we can combine the numerator here, so that's gonna give us t to the m over n minus 1 over 1 plus t dt. Let's just play around with this integral a little bit. Let's talk about the one we have evaluated in this video. It's the integral from 0 to infinity of x to the n minus 1 over, or let's say that it's x to the t minus 1 over 1 plus x dx evaluated to pi over sine of pi t. Okay, so we have proved this in that video. So if we consider writing t equals m over n here, so exactly if we talk about that integral, so integral from 0 to infinity of x to the m over n minus 1 over 1 plus x dx equals pi over sine of m over n pi. Look at this integral. This is the one that we have reached up to. Wow, this is really crazy, isn't it? So integral from 0 to infinity of x to the m minus 1 over 1 plus x to the n dx equals 1 over n, and we can replace this integral from this thing. So we can just write this as pi over sine of m pi over n, and hence we can say that integral from 0 to infinity of x to the m minus 1 over 1 plus x to the n dx evaluates to pi over n times sine of m pi over n. This was really crazy, and this was really easy to prove because we had this formula, we had this thing. So it was really good, guys, and we did it in under 8 minutes, I think. So again, guys, if you got to learn something from this video, just make sure to like, subscribe and share. And again, if you're having any kind of doubt, you are free to ask me in the comment section. I'll make sure to just reply over that. And just make sure to just come up in the next video. And yeah, thank you so much. Goodbye, guys, take care, love you. And just love mathematics because it is the thing to be loved.